Emily, what is your topic today?
Nernst equation.
Nernst equation. Okay, you can proceed.
So we are going to see about Nernst equation, and my today's topic is having three subdivisions. First, this Nernst equation's normal derivation and electrode potentials derivation, and how to apply Nernst equation for a cell EMF. So first, we are going to take the general formula, that is equilibrium reaction. A plus B gives C plus D, and Nernst equation is nothing but thermodynamics relationship between Gibbs free energy and reaction quotient and gas constant. So the formula for Nernst equation as derived from this, minus delta G, that is nothing but Gibbs free energy, is equal to...
Actually, this minus delta G means decrease in free energy.
Decrease in free energy.
So, for any chemical reaction, this free energy decrease is must. That indicates the progress of the reaction. What is this delta G? That is called Gibbs free energy.
Gibbs free energy.
What is that free energy?
It is
freely available energy. Is it not? It's not like that. But when you take energy, we can classify this into available energy, non-available energy. So let us not consider the non-available energy. We take some total energy, but we know that we are going to spend only certain amount of energy, and for which you can easily arrive at that amount of energy, that is the available form of energy. So that alone is taken into account. For example, if you go to any mall and you would like to purchase some t-shirts or pants or some dress material, so for which you got a certain price factor, for example, say about 2,000 rupees, but you got 5,000 rupees. Now what you are going to spend? Only 2,000 rupees. That is the available form of energy here you are going to consume, and that indicates the sales process. So similarly, for any reaction to proceed, the available form of energy for that particular reaction is very important, and that is why in thermodynamics we call it free energy, that is available form of energy. For example, when you want to break the egg, you don't require any hammer to break the egg, is it not?
Yes.
With simple slight touch, slight tapping, you can break it. Okay, so that amount of energy is more than sufficient to break that egg. That is called available form of energy. In that reaction also, it's called available form of energy. That is called free energy. So usually this free energy is accompanied by the progress of the reaction with negative factor, that is decrease in free energy. So for the progress of the natural progress of the reaction, what is the condition? Decrease of free energy and increase of entropy. Entropy is the another term. Okay, so that represents the degree of randomness of gaseous molecules. How frequently, how fast the molecules or gaseous molecules are rendering. That is a different concept. That is entropy. So in this case, decrease of free energy. Are you able to follow? So this is the thermodynamic property, right? Thermodynamic parameter. And what about that N of E, where what does N represent?
It is a
small n.
Small n represents number of electrons.
And F?
It's Faraday.
And E?
It's electrode potential.
So these are all the electrochemical parameters. So now it is very clear that there is a relationship between thermodynamics and electrochemistry. Okay, so Nernst equation is that relationship. Are you able to follow? So it connects the two different parameters. One is free energy from thermodynamics, and here EMF or potential from the electrochemistry perspective. Okay, right, proceed.
So here the reaction quotient is nothing but A. A is activity, and it is also called concentration. A is equal
What is activity?
It is the activeness of protons in a concentration, in a solution. So A is equal to concentration, and A is proportional to concentration. While removing this proportionality sign, we are going to introduce a constant. that is gamma C, that is A.
That is called the activity coefficient.
Activity coefficient. Here gamma is equal to 1, so
In
A
which case?
is equal to C.
In which case gamma is equal to 1? Strong electrolyte.
Strong electrolyte.
In weak electrolyte, there is some value. So in that case, you have to consider that one. Okay. Now let us go ahead.
Reaction quotient is equal to AC into AD by A.
What are those C and D? Products.
Yes, sir, products.
So activity of products, the sum, how to, that is, read that equation. The reaction coefficient is equal to what?
Product
The
of
product
the
of the
reaction and
activity of the product of the activity of the products divided by
the reactants
the
of
product of
the activities of the reactant in the reaction.
Right. So there is a constant.
Yes.
And that constant is the reaction coefficient. In case of acids, it can be called a dissociation constant A, Ka. In case of base, Kb. In case of any equilibrium, you can call it simply K. That is nothing but equilibrium constant. Is it clear? Right, proceed.
Okay, we are going to just take minus of Gibbs free energy, that is delta G is equal to minus delta G naught minus RT. This is nothing but natural log In.
What do you mean by natural log?
Sir, it is the...
It is log to the base E.
So we will just come to
and
log.
that is AC into AD, is it not?
Yes, sir.
Right.
So while deriving this equation, we will just get delta G minus of delta G is equal to NFE. That is nothing but number of protons and Faraday and electrode potential. So the next NFE, we know that delta minus delta G is NFE, right? So we can just substitute this in this equation. So it will come as NFE is equal to the same reaction here. And NFE is equal to NFE naught minus RT natural log, and this constant is, as Sir said, it is equilibrium constant K. So now dividing by 1 by NF, this NFs will get cancelled, right? So E is equal to E naught minus RT by NF. We are dividing it by 1 by NF. So RT by NF.
No, we are dividing by NF.
NF, yeah.
We are multiplying by 1 by NF.
1 by NF.
You have to either say multiplying by 1 by NF or divide by NF. So say multiply by NF.
Multiplying by 1 by NF. And now we need to convert this natural log, that is base E, into log to the base 10. So we are just going to consider E is equal to E naught minus 2.303 RT by NF log X.
Very good. So in order to convert the log to the base E to log to the base 10, you have to introduce the factor. That factor is
K.
2.303.
2.303. So yeah, now the basic Nernst equation is done. So we are going to see two subdivisions
that is,
with this.
You are written as a log X, it is log K. Okay, so that is the Nernst equation.
Nernst equation. So now we can just see it for electrode potential. M is nothing but metal. This is oxidation reaction, we know, and this is reduction reaction. We will often use reduction reactions only. So here we have to represent E as like this for electrode potential, and normal E for cell EMF. So we are just substituting all those Nernst equation in these values, and here product and reactant Mn plus by M. The concentration of any metal can be taken as M. So this M is taken as 1 and that is not considered, and E is equal to E naught minus 2.303 RT by NF log Mn plus. So E is equal to E naught minus 0.0591 by N. You can just substitute all those values in this, the constant values. So while multiplying, you will just get the answer 0.0591 by N, and log M power N plus.
It is not power, log M N plus, concentration of N plus.
Yes.
That is the ionic.
Yeah. Okay, now we can just see how to apply Nernst equation for cell EMF. Cell E cell is equal to E naught cell minus this value 0.0591 by n log k. We know how to calculate E naught cell, that is anode minus cathode. Now we are just taking this representation, that is galvanic
Cell representation.
cell representation. This double vertical line represents salt bridge, and this single vertical line represent the separation between the electrode barrier between the electrolysis and the electrode. Zn and Zn2 plus, Ag plus and Ag. So we are just having at cathode this reaction takes place, and we know that at anode oxidation takes place and cathode reduction takes place. So we should just write according to it. And the cell potentials are given. E naught cell is given here, and while cancelling out 2 electrons, we will just get the final reaction as this.
That is the cell reaction.
Cell reaction. So K is equal to.
You have got the cell EMF value also on the other side.
Yes, sir. So K is equal to Zn2 plus, as I said in this case itself, it is Zn2 plus by Ag plus 2, because we have 2 Ag, no? So we have to just multiply the value by 2. E cell is equal to E naught cell, they have just given E naught cell is equal to the same formula here, log K, that K is this value, so you have to just substitute it. And
so actually Ag plus concentration squared, not multiplication, squared.
Yeah, it is square, sorry sir. It is square. So while just multiplying and dividing, you will just obtain this value.
E cell value is
1.5.
So that positive value indicates what? It is the progressive reaction. So cell is the natural setup.
Natural cell.
Okay. If you are getting any negative value, you have to reverse it. You have to reverse the direction of the cell. Okay. Okay. Very good.